Hi, thanks for listening to this part of lecture. In the last lecture, we have introduced you to grain bill calculation and what are all the different malts and how they play a unique role. Uh, how they play a unique role in preparing beer of varying styles, like as the one which is mentioned here, different countries and different style of beers. However, the actual grain bill calculation was not covered to you in the last week. So now we will be concentrating on calculating the grain bill or the amount of, in other words, the amount of grain required to produce given volume of beer with a certain concentration of alcohol. So it was told to you in the last time lecture that the plan was to prepare an Irish red ale beer with a slightly elevated concentration of that of the American amber ale. To design such a beer, you were introduced to this chart, which is the chart showing original gravity and final gravity of various beer. And you can see different styles of beer has different original gravity, which is there in the and the the right hand side green one is original gravity, which is actually the solid content or the measure of glucose concentration in your wort. This is after mashing and ideally before fermentation. So, while the glucose concentration is determined by means of original gravity, the final gravity, the red one which is here, is actually the measure of alcohol content in the brew after which comes out of your fermenter. You may wonder how this original gravity and final gravity is measured. It's measured with a device like that of the one which is shown in the picture. This is called as hydrometer, and it is used to measure the original gravity and final gravity. So coming to the Irish red ale beer production with a higher alcoholic content as that of the American amber beer, means you can see the amber beer concentration is around 10 volume percentage. If the alcohol concentration or the final gravity to be high, accordingly the original gravity or the glucose concentration should also be high. The average value is taken somewhere here, that is 1050, and it's always only the last two digit is considered, as you know. So the value specific gravity or the of gravity unit of original gravity is 50, and yeah. So this is what we will take it from this particular slide which we left last week. Moving on to our actual problem of or to say the calculation of grain bill. What makes an Irish red ale a red ale is actually this the brown color that comes uniquely because of the mixture of these three malts: pale malt, chocolate malt, and Munich malt. So yeah, without much ado, we will go to the problem, solving the problem. uh, Grain bill, it's, in other words, it's a amount of grain required to produce an Irish red ale beer using a 40-liter homemade brewing system. This is the one which we have in our Irish pilot, in our pilot plant. And the original gravity and final gravity of 1050 and 1010 respectively, which we just discussed. So every system has its own efficiency. Every system has its own efficiency, and the brew efficiency of the one which we have in our pilot lab is 72%. The fine grain dry basis, that's given here. Pure glucose, the value for pure glucose is given. It's given for a particular reason. I will explain it shortly on what is this FGDB is and what is the significance of having the values for pure glucose. So next, the unique composition of the Irish red ale is given, that is 60% pale malt, 20% chocolate or caramel, and 20% of Munich malt. FGDB is the maximum amount of solids that can be extracted from particular type of malt. Now sometimes the FGDB for various malt will be directly revealed in the unit as that of the pure glucose, that is liter degree per kg. However, if FGDB or extractability is given in terms of percentage, like here, you know, then we must use the pure glucose as a reference, right? And calculate it accordingly. We will see that when we come to that stage of the question. So now the given data here, all the data that is given here may not be in your exam question paper. So the students are expected to have previous knowledge on all the data given here before coming to an exam. The only variation that one can expect is it's the the capacity of your brewing system may vary, and the efficiency also can vary. So otherwise rest of the things are considered to be constant, so you are expected to come with the previous knowledge on that. To explain more on the fine grain dry basis, it's just a measure of the maximum amount of solids that you can extract from a particular type of malt. Okay, moving on to the equation or the formula for grain bill calculation. Let us look here that the grain bill is actually a total sugar extract that is divided by brew house efficiency and fine grain dry multiplied by fine grain dry basis. You can see there is an inverse relationship between the grain requirement and the brew house efficiency as well as with the fine grain dry basis. So as the efficiency is high, as the extractability or the FGTB is high, your grain requirement is going to go down. So let's place all the given data that we saw in our previous slide. So we'll place it in a pictorial form. So the idea is to produce Irish Red Ale, and the composition is pale malt of 60%, chocolate or caramel malt of 20%, Munich malt of 20% again. It is mashed to get original gravity of 1050, and remember to consider only the last two digits, which is 50. So when we brew this stuff in a 40-liter tank having yeast, what we get is a brew that contains potentially a alcohol concentration or alcohol by volume of 10 volume percentage, and the final gravity is 1010. Again, you should consider only the last two digits. So we will go on substituting these values into the grain bill. So yeah, first thing that has to be considered is total amount of sugar. The total amount of sugar can be derived by multiplying the wort volume with your original gravity, and we know the wort volume that you can produce maximum is 40 liters and the original gravity is 50. Upon multiplication we get 2000 liter degree, which is the total amount of sugar. This is total sugar. Now the Irish Red Ale beer is made of three different malts: pale malt, charcoal malt and Munich malt. So it is essential for us to find the sugar contribution from three different malts. So that we will do it in our next slide. The amount of sugar from different malt needs to be calculated. The Irish Red Ale beer, as it's shown here, the pale malt, charcoal malt and the Munich malt, 60%, you can see 60% means 0.6 into 2000. When we multiply it, we get the sugar contribution from pale malt, which is 1200 liter degree, and the sugar contribution from chocolate malt is 400 liter degree, and the sugar contribution from the Munich malt is once again 400 liter degree. The unit in all cases should be liter degree, or in other words you can mention it as GU or gravity unit. So once when we finish the grain, the total amount of sugar for each individual malt, the next thing that comes is your brew house efficiency. Since we mixed the malt, all three malts together and brewed it, the brew house efficiency is going to be same in across all pale malt, chocolate malt and Munich malt. You can see this total sugar varies as we observed in the last slide, but the brew house efficiency remains constant. So for us to solve this grain requirement, we have left out only with finding this extractability or fine grain dry basis. Moving on to the FGTB calculation, you can see some malting industry, they, as I said it in the first few slides, some malting industry, they reveal their FGDB as in liter degree per kg. However, if it is mentioned in percentage, that's when we have to take help of the pure glucose, because this is the reference with which the percentage needs to be converted into liter degree per kg. So for the Irish red ale beer, again it's 80 percentage extractability is there. So multiplying 384 of pure glucose with 0.8, we get 307.2 liter degree per kg. The same goes with the chocolate malt also. You can understand, or you can infer something here, that the extractability of pale malt is slightly higher than your chocolate malt, because this chocolate malt is produced upon passing hot air. So some kind of caramelization is going on there. That's what it actually brings the brown color. So it brings the brown color, but some sugars has got spoiled, or it has got caramelized, whereby the extractability value also drops down from 80 to 75 percentage. However, for the final Munich malt, we can see that the extractability is once again retained 80 percentage, and we can see once you multiply this with the 0.8 with the pure glucose, you are getting 307.2 liter degree per kg. So now we have all three different components: the total amount of sugar, the brew house efficiency, and fine grain dry basis for three different malts. So when we do this, the total amount of sugar for pale malt is 1200 liter degree, and the brew house efficiency is 0.72, and the fine grain dry basis for pale malt particularly is 307.2 liter degree per kg. And upon calculating, we get 5.42 kg. Always try to see whether your the unit also comes consistent or not. That is very much essential. So here you can clearly see liter degree gets cancelled. The only thing that remains is kg, kilograms. So the pale malt is always measured in kilograms. So what we are doing is correct. We can move again with the rest of the two malts also, that is choco malt. We can see 400 liter degree, because the contribution is very less, and then 0.72 brew house efficiency. Fine grain dry basis of 288 liter degree per kg. This yields 1.93 kg. And for the Munich malt, it is once again 1.8 kg. So the cumulative grain requirement is, we just add everything together. So we get 9.15 kgs, which is your grain bill, or to say the grain requirement to produce 9.5 kg is the grain that is required to produce an Irish red ale beer having a potential alcohol content of 10% volume by volume. In this lecture, we covered grain bill calculation. In our next lecture, we will see the numerical problem related to hopping rate calculation. And thank you.